Hello again, and we're going to be working with powers and roots today. Let's start off with powers and exponentials. I'm going to kind of do it all together. Anytime we're multiplying integers, we can, if they're the same integer, like 2 times 2 times 2 times 2, they're the same base, we can raise that, count 1, 2, 3, 4, raise that to the fourth power. That's called an exponent, all right? It's also called a power, okay? Powers, roots, and exponents, okay? So when you hear of a power, that means that you're raising something to a repetitive state. In other words, 2 to the fourth power means that you're multiplying 2 times 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So 2 to the fourth power is 16. Now, we're going to get into some rules with exponents, and we're going to get into all that good stuff. But right now, we're just talking about basic rules with numbers. Now, if you notice this number right here is even. Okay, that 4 is an even number. Anytime we raise something to an even number, and I'm just going to put a block here, and I'm going to put an even exponent right here. And this number can be -5, it can be +2, it can be 1/2, it can be 0.01. Anytime we raise a number to an even exponent, we're going to get a positive number. And the reason that is, as I said in the integer video, the one before this one, anytime you raise something to an even number, you're multiplying it an even amount of times. A negative times a negative and a positive times a positive is positive. So no matter how many times you do it, if it's even, it's going to come out positive times positive times positive times positive, no matter what you have. Give you an example. -2 raised to the fourth power. Okay? That's going to be -2 times -2 times -2 times -2. -2 times -2 is +4. -2 times -2 is +4. What is +4 times +4? +16. So it doesn't matter what you have, if you have a +2 to the fourth power or a -2 to a fourth power, you're still going to get a +16. So the property that goes with that is any number raised to an even power is always going to give you a positive. Any number raised to an odd will give you the same number, same sign of that number. So if this is a positive and it's raised to an odd, you're going to get a positive. If it's a negative and you raise it to the odd, you're going to get a negative. Example, -2 raised to the third power means -2 times -2 times -2. -2 times -2 will give us a +4. +4 times -2 always gives us a negative number. So I started with a negative raised to the third power, and I ended with a negative. Because with an odd power, whatever you end up with, you're going to get as your answer. So this is a couple of good rules to remember. I'll put them in red. And those rules you need to remember because you're going to see them again. Now, I also need to tell you one other thing. if you notice in these problems I just showed you, I'm going to take my highlighter and I'm going to change it to yellow. These parentheses are around the sign. Everybody see that? When the parentheses are around the sign, this applies. But if you are given this, that's not the same as this. These are not the same. Okay? And you need to make a note of that in your notes, because this means negative 2 times 2. The 2, the exponent, is only going with the number. It's not going with the sign. So this would be a negative 4. Negative 3, I'll make that a 3, raised to the third power. That's going to be negative 3 times 3 times 3, which is negative 27. So, whenever I start exponents, I always make sure that students realize that these two are not equal. These two right here are two different animals. So you need to make sure you understand that. If the negative is in the parentheses, that means that this rule applies over here. If the negative is not in parentheses, that means you just put the negative out in front of the number. Okay? Now, the opposite of a power is a root. And we're going to talk about that in just a minute. I'm just going to make sure everybody understands that and make sure you've got that written down. When you're talking about a root, and the best way to explain a root is to show you the power, or use the power to show you. 5 times 5 is equal to 25. Or 5 raised to the second power is equal to 25. That's called an exponent. Now, to undo an exponent, you take the square root. Okay? To undo an exponent, you take the square root. So the square root, and let's talk about the square root. What is a square root? Well, this is what a square root looks like. That's what a square root looks like. It's got two parts. Let's name those parts. This part is called the index. This part is called the radicand. And under, the radical. The radical. And under the radical is called the radicand. Okay, and usually that's a number or a variable. Now, when you take the square root of something, and I'm going to go over here, and I'm going to write down, and I tell all my students they should have a card, an index card, one of the small index cards, and they should put x squared here, x to the third here, x to the fourth here, and x to the fifth on the end. And I tell students that they should do 1 squared is 1, 2 squared is 4, 3 squared is 9, all the way down to 15 squared is 225. And I tell them to do 1 squared is, or cubed is 1, 2 cubed is 8, 3 cubed is 27, and I tell them to go down to like 5 or 10 cubed is equal to 1,000. Okay, and x to the 4th, 1 to the 4th is equal to 1, 2 to the 4th is equal to 16, 3 to the 4th is equal to 81, and I tell them to go, I think, to 5. You can go as far as you want to. 5 to the 4th is 625, I believe. And then up here, 1 to the 5th is equal to 1, 2 to the 5th is equal to 32, 3 to the 5th is, and I tell them to go down to 5 here. 5 to the 5th. Okay? And I tell them to make a card like this whenever I'm in a classroom, because it pays for students to know to think of perfect squares, perfect cubes, perfect fourth roots, perfect fifth roots. Because in a book, they may ask you to take the square root of some of these numbers, or the third root of some of these numbers, or the fourth root of some of these numbers, or the fifth root of some of these numbers. And you have to be very familiar with those numbers. I didn't say memorize, I say familiar. You need to be very familiar. Everyone should know this column. Everyone should know the times tables to 15. Okay? Now, if I tell you that 25 or 5 squared is equal to 25, then I can undo that by saying, and I'm going to put this in blue, the square root of 25 is equal to 5. I can undo in other words, the square root of 5 squared. What does the square root symbol do to the exponent? It cancels it out. So you can think of these guys as opposites of each other. Okay? The square root undoes the exponent, and the exponent undoes the square root. So if I ask you what's the square root of 64, well, you think of your multiplication tables. 8 times 8, or 8 squared, is equal to 64. Therefore, the square root of 64 is equal to 8. So it's very important that you understand the perfect cube, the perfect squares, the perfect cubes, the perfect fourth root, the perfect fifth root, because you need to be aware of these numbers, and what goes with these numbers are these numbers over here, and the same here. And if you're not familiar with these numbers, it's going to be very difficult for you to remember what's the square root of 64, what's the cube root of 8, what's the fourth root of 16. You're going to have to actually go and research it, because you don't have this little index card with these columns on it. And I would highly suggest for future math classes that you have that index card and fill it out as much as you want. And that way your brain and your eyes will pick up those numbers, and you may remember them even though you don't know you remember them or not. So that's a little hint for something, Getting back, if I ask the cube root means that you're in this column. The cube root means that you're taking the cube root of 8, or the cube root of 27, or the cube root of 1,000. The fourth root is so on. So you can rewrite and undo, and I'm going to clear the page, and I'm going to give you a couple of examples. 4 to the second power is equal to 16. Therefore, the square root of 16 is equal to 4. Now, we're going to get into a little bit later that the square root of 16 is positive or negative 4. We'll get into that a little bit later because 4 times 4 is equal to 16 and negative 4 times negative 4 is equal to 16. Okay, we'll get into that later. When you get into algebra, you will get into that. But right now, we're just going to say the square root of 4 is 16, or the square root of 16 is 4. So let's do another one. 10 squared is equal to 100. Therefore, the square root of 100 is equal to 10, or, and later on in algebra, positive or negative 10. Now you can do the same thing with a cube root. If I write 10, or not 10, because we don't want to get that high yet. Let's go with 2 to the third power is equal to 8. Therefore, the cube root of 8 is equal to 2. Now notice, the index changed. Sorry. The index changed. Do you have to pay attention to that? Yes, you do. You have to pay attention to the index of the radical because sometimes on a test, they may throw a fourth or a fifth root in there and you think it's the square root, and that's not correct. All right? Now, what if you see a fraction as an exponent? Well, I'm going to go ahead and give you some rules for algebra. And I'm just going to give them to you and you write them down and they're for the future. But no, I better not. I better wait. This is a basic math review, so we're going to wait. But you can have a number raised to a exponential, rational exponent, sorry, a rational exponent. A rational exponent. I'll give you an example. 4 raised to the 1/2. 64 raised to the 1/2. 100 raised to the 1/2. If you see a rational exponent, write this down. That is exponent over index. So that's the exponent, that's the index. So I'm going to rewrite this as the square root of 4 to the first power, the square root of 64 to the first power, and the square root of 100 to the first power. And of course, that's 2, positive or negative 2, positive or negative 8, and positive or negative 10. So if you ever see a number raised to a rational exponent, which is a 50-cent word for a fraction exponent, an exponent written as a fraction, then you're going to be taking the indexed root of that exponent. Let's see, index, 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 and then the exponent, exponent, exponent. And I can rewrite them. If I have, let's say I have, and this also with the cubes and the fourths, if I give you this on a test and say, I'm going to take the cube root of 8 to the second power, then I can rewrite that. There's my exponent, there's my index. What is it? Exponent over index. So I can rewrite that as 8 to to the 3/2 power. How about the 5th root of 2 to the 4th power? Well, that's 2 to the 4/5 power. So I can rewrite a radical as a rational exponent, or I can write a rational exponent as a radical. This is something that you need to put along with your even and odd exponent, that you can rewrite a radical as a exponent, a rational exponent, and you can write a rational exponent as a radical. Now again, you're going to see this again in algebra when you get into the pre-algebra and Algebra 1 review and Algebra 2 review. Remember, this is basic math, so I'm not going to cover a lot of your exponential rules here because it only pertains to integers, taking the square root of an integer, not a variable. Now, the next thing I'm going to cover is going to be simplifying. This is where that index card is going to come in handy. All right? That index card, I told you to write an index card and divide it into 5 columns. Put x squared up here, x to the 3rd, x to the 4th, x to the 5th, and then do 1 to the 2nd is 1, down to 15 to the 2nd is 625, and so on. Fill it out. Because I'm going to give you a problem like the square root of 45. The first thing you should say to yourself, I don't know the square root of 45 because it's not on my index card. Because the closest thing you got to the square root of 45 is the square root of 49, which is what? 7. So you can't find the square root of 45. There's 2 ways to find the square root of 45 without having a perfect square or a calculator. One is to simplify with radicals. Simplifying with radicals. So I'm going to bust this up using my perfect square index card and using my multiplication tables. I'm going to say, okay, that's 9 times 5. Why did I pick 9 times 5? Because 9 is a perfect square. How do you know it's a perfect square? Because you know your index card over here. That's why the index card is so important. Because I can ask you to break up a perfect cube also. We'll do that in just a minute. But what is the square root of 9? 3. And the square root of 5. And I just simplified this into a simplified term with radicals. Now another way, and this is kind of approximate, and I'm just going to show you this because the square root of 49 is equal to 7. The square root of 36 is equal to 6. Halfway between 6 and 7 is 6.5. So you just kind of find the middle over here. This is called interpolation. 36 to 49 is 13. Half of 13 is 6.5. So that's going to be 42.5. We want 45, so we know it's in the upper echelon up here. 42 to 49 is 7. Half of 7 is 3.5. So the square root of 45.5 is equal to 7.75. So I'm going to say it's probably around 7.7. Or 6.7, sorry. 6.7. Now that's a very approximate, unofficial way of finding a square root, but it's, you don't have a calculator and you can't, use the radicals for directional purposes, then you can estimate. That's called estimating a square root, and you can use the approximate, which is a squiggly equal sign with and I'll say it's around 6.7. And that's going to be how you find it if you guesstimate. But let's do the cube root of 16. Well, you're not thinking about the square root now. You're thinking about the cube root. Cube root, 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, and 10 cubed is 1,000. Okay, 16. Well, I can't use 27, that's too high. I can't use 1, so I'm going to have to use the cube root of 8. So I break this up into the cube root of 8 times the cube root of 2. And what's the cube root of 8? 2 times the cube root of 2. And that is how you do the square root. You're simplifying by breaking it up into perfect squares. The perfect square here, is the square root of 9. The perfect cube here is the cube root of 8. Now, you wouldn't know that if you didn't have this index card, or you knew your perfect squares from previous classes or perfect cubes. You need to make an index card and know your perfect cubes, squares, fourth roots, fifth roots. Okay, let's do another one. Let's do the square root. Oops, I'm sorry. Let's do the square root of 54. And the cube root of 48. And the fourth root of 32. Okay? And when you do not see a number here, when that is blank, it's assumed to be a 2. When you see a radical without a number there, it's assumed to be a 2. So I'm going to break this up into the square root of 9 times square root of 6, 3 times square root of 6. I'm going to break this up into the cube root of 8, cube root of 6, 2, cube root of 6. I'm going to break this up into the fourth root of 16, fourth root of 2. Fourth root of 16 is 2. Fourth root of 2. So, if you want to learn how to do powers and how to simplify powers, my advice to you is to make sure you have that index card and you fill out that index card with those perfect squares and perfect cubes so you can have everything, ready to go. And you would be thinking in terms of squares, cubes, or fourth powers or fifth powers.